that data will be used for training purpose, and based on that training, the machine learning model will take the decisions for us. Okay, so ML provides the data driven decision making capabilities, right? Data driven, so all the decision making, right, which is uh, all the decisions which are taken by the machine models, the machine learning models, are based on the data. So whatever data we generally use for training purpose, based on those, it takes the decisions, right? And why they take the decisions? To improve the additive manufacturing process, right? Now the question is, why to integrate ML in additive manufacturing? So in my last lecture, I talked about the various stages of additive manufacturing, right? So where from we start? We start from CAD model, CAD model, right? Second is, after CAD model, we go for the STL file generation, and then third is slicing, slicing, right? And after slicing, we go for tool path, tool path, right? Tool path generation, and after that we go for 3D printing. 3D printing. So you can see actual part printing is done here only, here. But before that, we have to go through the different stages in which CAD modeling is also included, right? So we can apply machine learning at various stages. We can apply at the stage of CAD modeling as well. We can apply the machine learning at the STL stage as well. We can apply machine learning based at the slicing stage as well, right? And tool path is also one of the stage. Here also we can apply machine learning, and on 3D printing stage, at 3D printing stage, we can also apply machine learning, right? So I will be talking about the different things, like for example, here I have shown the why this integration is required, right? How this machine learning empowers additive manufacturing. So here I have taken two major, the areas where machine learning has contributed most, right? So here you can see that process optimization. So data driven tuning of parameters is possible with machine learning, right? Real time fault detection, because I told you, with an open loop you cannot get the desired quality or repeatability in the product. ठीक है, आप you have, so for example, you have printed one single part with good quality, right? But again you are going for the same part printing, you may not have the same quality for the second time, right? So how can you ensure these things? By just taking the real time data. If fault is coming, right, in the system, how to detect that fault? So this real time fault detection is possible. So immediately it can identify the anomalies using the sensors for data and image analysis. You can do this also. So as a result, what happens when you apply machine learning and additive manufacturing? What happens? Cost and time reduction. It minimizes the rework, right? It optimizes the material use. Otherwise, if suppose you are not you have not applied the machine learning on additive manufacturing, then what will happen? Machine will run continuously. It will deploy the material continuously on the build platform, right? If you are not present there, suppose the part is to be printed in 10 hours, for example, right? And you are not there, you have full trust on the machine, for example, and you have just loaded the file on the machine, and after starting the machine, suppose you went from there, right? Now after 1 hour, suppose some fault has been come into the picture. Now because machine do not have the capability to take the decisions, right? Machine will continuously deposit the material for 10 hours, right? So in this way you are saving the material wastage, you are also minimizing the rework, right? So this is possible only with machine learning. And also quality assurance, this is very essential if you are suppose planning to use additive manufacturing in the industries where industries needs the quality assurance, right, from the manufacturing process, then only they can deliver that product to the customer. So accurate prediction of part quality is possible with this, right? Or damage and accuracy and defects can be predicted by just using the machine learning. Okay, now if you look at the AM again, right? If you look at the AM, as I told you, it involves the complex and non-linear processes, right? Nothing is linear there, right? Relationships may be non-linear, and it's very complex because I have already shown you the images of the different additive manufacturing systems. So it is so very complex systems are involved, right? Non-linear processes are involved. So if you go for manual parameter tuning, it may be time consuming, right? Manual means, for example, here I have taken the case of FDM, right? So FDM, you can see the parameters for surface roughness. These many parameters are responsible. So here the number is 5, right? Then for dimension accuracy, again 1, 2, 3, 4, 5, 6, 7. So here we have 7 parameters. Here we have, for example, 5 parameters. And for build time, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 parameters are responsible. Flexural distance, again 7 to 8 parameters. For compressive strength, again we have almost 8 parameters, right? And here we have almost 10 parameters. So if you look at the list of the parameter, right, and you go for manual parameter tuning, for example, you are changing layer thickness one by one, you have taken, for example, 5 levels, right? And for build orientation you have taken 3 levels. For print speed, again you have taken 4 levels. For raster width, again you have taken some levels, right? So if you go for manual parameter tuning, what do you think, how much time it will take? It may take 1 year also, right? It will be time consuming and error prone because you are doing the manual, manual intervention is there. So this is the reason we should go for the integration of ML in additive manufacturing, right? So apart from these parameters, variation in the material and environmental impact part quality, this is also very, very important. Variation in the material and environment impact part quality. Variation, if any variation is there in our country, in summer almost sometimes the temperature is up to 47, 48 degrees centigrade, right? In winter temperature drop to the 2 degrees centigrade or 3 degrees centigrade, 0 degrees centigrade sometimes, right? So this variation also, very important, and it may impact the part quality in case of FDM. So that's why, when you integrate ML in additive manufacturing, it will cover the range, right? It will give you the solution by considering these aspects also. Now, what are the different categories of learning, machine learning? Right? So there are two categories. One is supervised learning and second is the unsupervised learning. So in supervised learning, the algorithm learns from level data. right? Level data means here we provide both the input and correct output. Input and correct output. What does it mean? For example, I have performed few experiments, right? For example, I have performed 20 experiments, right? So I have list of the inputs for these 20 experiments. So corresponding to these inputs, I will find out the correct output, right? So this is one of my data set. So by using this data set, I will supervise my model, or I will train the model, right? I will train the model. So what is the goal behind the supervised learning? Simple is the to learn a mapping function from inputs to output levels. So for example, inputs are X, output levels are Y, right? So this mapping function will be used to predict the output for new unseen data. Unseen data means we can feed any data in that range, right? It will give a output to me. Okay, like if I take a case of spam detection in the Gmail. So whenever you receive an email on Gmail, what happens? If the text is related to some spam related to spam, Gmail will suggest you this might be spam. So be cautious, right? So you can decide whether it is spam or not spam. So you can, if it is spam, it will automatically send it to in the spam folder, right? So classification basically is generally done here. Regression analysis or regression model can be used. For example, for predicting house prices, temperature forecasting. So these are the leveled, sorry, without leveled responses. So after that, the clustering is done. It makes the groups. This is the level data, and for these level data, we have defined the output. So this shape is the output is camel. So we have taken these two input data and the correct output. So both we use as a input or true as a data set, right, to train the model. So this you can see here we are feeding this data, and after processing, right, here what will happen, it will give us the correct output, right, camel. Whenever we will feed these three, okay, just to check the accuracy level of the model, right, model, here it is giving us the correct output now. So whenever we are feeding these three images, it is telling us this is elephant, this is camel, and this is cow, right? Now in the unsupervised learning, here we have given this data, okay, two cow, two camel, and two elephants, okay. So based on the interpretation, it has made the clusters, right? Cluster means this is one cluster, this is second cluster, and this is third cluster, right? After processing, here you can see it is giving output, three clusters. Okay, on based on the similarity, right? Because every animal has four legs, right? One mouth, but there is a change in the shape. Based on considering the shape, it is giving us the value. Okay. So now what are the applications of ML in additive manufacturing, right? So if I talk about the applications, here I have listed few points like design optimization, process parameter optimization, defect detection, in situ monitoring, predictive maintenance, mechanical property prediction, right? Not mechanical property, any property, right? It may be electrical, it may be the thermal or mechanical property related to the other things as well, domain as well, right? So design optimization, here we can deal with the material design as well. We can deal with the CAD optimization. Under the process parameter optimization, we can also apply the machine learning, right? And it will reduce the trial and error, right? As a benefit, we will get this, okay? Defect detection. So if any defect is there, layer defect is there, so we can just capture that defect by using the sensors and images, okay? And after comparison, we can detect the defect in the parts. In situ monitoring, continuous quality monitoring during printing, right? Continuous quality monitoring during printing. So this is also possible with the machine learning. Continuously we can capture the images, right? Capture the data. So that big data can be can be captured and can be analyzed, right? And based on that data, we can take some decisions in situ monitoring. So immediately suppose we find the data during printing, machine will automatically switch off, for example. We have written the code in that way. Predictive maintenance, forecasting failure in hardware components. So I will be talking about this also, hardware components. Then mechanical property prediction. We can use machine learning to estimate the tensile strength, compressive, electrical, surface finish, etc. I will show you some of the case studies here related to this as well. Okay. So I have two case studies. I will show you two programs. Here one is related to the process parameter optimization and second one is the related to the mechanical property prediction, right? As I told you, this is one of the area, right? That is the design optimization, right? So I assume you are aware with this generative design. Nowadays it is very popular. It is becoming very popular because it is the machine learning driven generative design, right? So here I have taken one example. Okay, this example, right? So earlier, for example, without generative design, this was the CAD design of the model or of the component. But after applying the generative design approach or the machine learning, finally we have converted that model into this shape, right? So what we have done here, we have preserved the location and the features of the uh, of this component. Okay, so these features are intact. Like suppose here we have 1, 2, 3, 4, 5, 6. So 6 holes are there, and their locations are 2 are on the left side, 2 are on the right side, and 2 are in the center. But their orientation is along the x-axis, for example. So now if you look at this part also, here we have 2 holes on the left, 2 hole on the right, and 2 holes on the center side. Okay, but what has happened? The material, earlier material was completely solid, but now after applying the generative design, it has provided us the optimized geometry that has the less weight and improve strength. So right. So now the question is how these things are achieved. So what you can do, you can refer any good software which is capable of CAD modeling, right? I will suggest you one software, FreeCAD. Okay, FreeCAD is a software which is totally free. No need to purchase FreeCAD. Search on the YouTube how to do generative design using FreeCAD. You will get many tutorials, right? So here you have to just apply the boundary conditions, how much load you want to apply here, right? What is your requirements? So those requirements you can feed. After that you will get these shapes. Okay, you can go for the multiple iterations to get these shapes. So now this shape looks very good in terms of its look, right? So we have not basically compromised with the quality, right? We have just improved the design or reduce the weight of the product by applying the generative design. So this is possible only with the machine learning, right? Here also I have given one example of Autodesk NetFab and ANSYS Discovery, right? So these two software also can be explored, right, for improved AM output. So here I have taken the example of Airbus. This is a Airbus 350 bracket, right? So Airbus basically has fabricated or this modified their bracket, original bracket into this form. So this is the conventional design of the bracket, right, which was earlier fabricated by them, and this is the improved one. This is with the generative design, right? And this is the bracket which is used for landing gear, right? So after applying the generative design, the weight has been reduced by 29%, right? And the stiffness is intact with at 100%. So you can see we have not compromised with the stiffness which was required in this case. However, we have successfully reduced the weight of the product, because for a for an aeroplane the payload is very important factor, right? So if you are using, for example, multiple brackets or multiple components like this, you can successfully be can be achieve you can achieve the the you can reduce the payload of the aeroplane by just incorporating these kind of component. So this is one area where you can incorporate this machine learning, right? Second is the process monitoring and control. Process monitoring and control. So process monitoring, basically here I am talking about the real time monitoring of the machine and its control. So conventionally what happens, conventionally quality inspection is conducted after additive manufacturing. After additive manufacturing means after part fabrication we check the quality of these specimens, right? But as a result what happens, it may waste more time and money, as I told you earlier also, right? Now in order to avoid this, what we can do, we can make a system, okay, or we can incorporate some the sensors and some data processing related components which can process the which can monitor the whole process, right, and controlling it can provide us, okay. So in the conventional way, if you look at here this is the these are the components, right? These three components are required. If you are having an open loop system, it has only controller, it has actuator, like actuator means the temperature, heaters, right, sensors, okay. So these component actuators are there, but they are not taking any feedback from the system, from the environment. Now controller actuator AM process is there in the normal conditions, but when you apply this particular machine learning, है ना, so what happens, it add some more few components here, that is a fault handler, fault diagnosis, defect handler, defect detection, observer, okay. So these things are added, okay, and here we set the points, here we have just feedback, this is a feedback loop, okay. So here we have a data receiver which will receive the data. Based on this it will take the decision, right? It accordingly the controller will take the decisions. Suppose there is a signal from the environment that some problem is related to the deposition speed, so controller will automatically control that speed based on that data, okay. If suppose there is a defect related to temperature, excess temperature, so again controller will lower down the temperature of the nozzle, okay. So in this way it will monitor the machine and control the machine. Okay. So in order to do the real-time monitoring, we incorporate some sensors, we incorporate cameras, right, which monitor the printing process continuously. If any defect is there, obviously we get the feedback. Okay. Accordingly, controller takes the decision. So here I have listed the key actuator which are generally used, right, and their function. Okay. So in FDM we use stepper, servo motor, heaters, extruded driver, linear actuators, right? So and their functions are also listed here. Okay. SLA and DLP, galvo mirrors, DLP light projector, Z-axis linear actuator. So these are the actuators which are controlled basically, or which are used for controlling purpose. Okay, in order to enable the real-time monitoring of the machine. And here we have the traditional mitigation strategies if we have some defects. For example, if we have a defect like warping, for example, right, in case of FDM. So what we do, it is related to the heated bed, right? So we can go for the optimization of heat bed temperature, enclosure, bed leveling, right? Layer delamination is there. So we will in the traditional way, if we suppose try to overcome these defects, we will deal through this way, right? But with ML, what we can do, we can use, we can first of all we can prepare a data which will have all kind of defects. After that, we will go for the defect classification using the image data, right? And then we can apply some algorithms which will provide us the detail of the process parameters. So those process parameters can be used further in the future so that those things can be avoided, right? Or those parameters can be rectified. Okay. Uh, so here I have listed some things for some other process as well. Okay. So here General Electric Additive, so they employs the closed loop systems in the machines to reduce the porosity in the parts by 50%, improving quality significantly in the of the parts. Industry players, here I have mentioned two industry players, Sigma Labs, Identify, 3D Specialize. Okay, they have integrated the ML based process control for AM. Third application is the material development, where the accelerated discovery of the materials is possible. Okay, how it is possible? Because ML model can predict properties of thousands of potential materials rapidly. As a result, reducing the need for expensive and time consuming experiments. Otherwise, in conventional way, what we do, we make material, right? Then we test it, then we go for characterization. So a lot of things, are involved whenever we go for the new material development, right? But with ML, we can save the time, huge time can be saved, because ML model can predict the properties of the potential materials. We can mix two material, we can mix three material, we can make that some kind of models, right? Or we can feed the material properties there, and it will give us the output. What kind of output we are going to get by using that new material? Okay, so we can apply inverse design approach. Inverse design approach. Inverse design means, currently what we do, we design a material for some application. So application is known to us, and for that we are doing the experiments, we are developing the materials. But here we can predict the material structures, because desired property we know, right? And for the desired property, what should be the material structure that can be predicted by the machine learning? Because nowadays we develop the material, then we try to find out the application, right, based on the results. But here I am talking about the inward design of the material, right? We know the application, and for that application we are going reverse. We are predicting the material property, material structure, what kind of structure will be required to just get the results, okay, to just cater the demand, right? Second thing is the property prediction. So property prediction here, as I told you, we can develop some ML models which can be trained based on the existing data sets. So if you have active data set with you, mechanical related to mechanical property, related to thermal property, related to electrical and or optical properties, you can predict the properties of the materials with high accuracy. So this is one of the area that can be uh, explored through ML. The predictive maintenance also can be done, right, because we know the pattern of the actuator, right? So we can use some sensors which will record the data continuously. If any deviation in the data is found, right, immediately the machine learning model can provide us the details. Based on those details we can take the decisions. Okay, predictive maintenance is required, for maintenance activity will be conducted after few weeks or 2 weeks, right? Now if I uh, yeah, now I will show you the case study, right? I have two things with me. So I'm opening the Google Colab, right? Sir, is my screen visible to all?
Yes, sir.
Okay, okay. Thank you. Uh, just wait, it is taking some time. Okay, mounted. Where is the drive? Just wait. Let me reload. Okay, so here I have taken this code. Sorry. So yesterday I have made this code, okay, so where I can show you uh, see, so this is the code, right? Here I am just removing these things, code cell, I am deleting these things, okay. Okay, now what will happen if I see, if I play, if I run this code, now it is just wait, okay, this is to be deleted actually. This is to be deleted. I have already mounted my drive as well. Delete this thing also. Please, where I have. Execution code output. Actually, yesterday I have executed code different way. That is why these outputs are. एक second, just wait. I am going to open my upload this one, right? The same problem can be there from I'm going to okay, let me run this code, okay. Here, this code actually I have written yesterday for process parameter optimization, right? So now it is giving me the something is there that I am not able to recall. See here what I have done actually. Here I have taken four process parameter: layer height, road width, deposition speed. Sorry, three process parameter, input process parameter, and this one is the fourth one. This is the output, right? So corresponding to these process parameter, for layer height, I have taken the value 0.10, 0.20. So basically, I have taken three levels here, okay? And road width, I have taken three levels: 0.3, 0.4, 0.5. And similarly, deposition speed 1000, 2000, and 3000, right? So corresponding this data, we perform some experiments, and after that, we obtain the value of surface roughness corresponding to each and every combination. And after that, this is the roughness, right? This is the roughness corresponding to these inputs combination, okay? 0.10, 0.3, and 1000. So corresponding to these three, the output is 11, right? Corresponding to this, the output is this, okay? Now, no, up to now, why it is not, yesterday it is not taking library actually. See, I will provide this code after rectification, okay? And what you can do, I will just explain you this code, right? So I have trained my model using this data set, right? This data set, and now here I have trained my model by considering these values: layer height, road width, and deposition speed. And after training, I have made a model, okay, predicted model, where here, for example, here I have taken the once I will run this program. So here I have taken only 10 trials. So I can change it to 100, right? I can change it to 1000. So based on these trials, it will give me the best possible combination of three input parameter and corresponding surface roughness value, which is not, I don't know why it is not running. I have to check thoroughly. Okay. So it is the basically the idea, okay? So I will provide this code. You just open this code in the Google Colab, and I will provide the data also, right? So this data, when you will use this data for training purpose, it will give you the output, right? It will give you the best combination of layer height, road width, and deposition speed, and corresponding to those optimized value of these three parameter, what will be the surface roughness. This will also be determined through this model, right? Now the second, let me say this one. Yes, see, I have, let me check whether it is working or not. Executing, 1 second. I don't know, some error is coming in my laptop actually. Yesterday I learned this uh, code on my desktop. It was working. I don't know what is happening right now, but due to time restriction, I am not able to figure out the error. Okay. So if you have any query or any feedback regarding my lecture, you can ask. Because already I have taken seven more minutes, right? So these two data I will share with you. You please check on your system. Okay, after just opening the Google Colab.